Okay, so looking at your first example, it says we want to find a measure of what segment? XZ. So let's look at our picture. What two small segments is this made up of? XY and YZ. And if I want to find out how long the whole thing is, what do you think I should do? Add them. Let me get my calculator. We have decimals, so we're going to add them. But I have the two small segments, XY plus YZ. If I add them together, that gives me XZ. So I'm going to do this in the calculator, 11.3 plus 3.8, and it would give me a total length of, whoops, I don't want highlighters, I want pens. The length of XZ, you notice I put it without a bar over it, is equal to 15.1. And it's actually centimeters, but I don't count off if you don't put the units. Just remember, units, they will ask for those on the EOC. Everybody okay with that one? All right, let's take a look at the second example. Look at your picture. Look at what it's asking you for. What is your big segment in that picture? PR, that's the whole thing. How long is PR? 13 feet. And then what's one of the small segments that it tells you the length of? PQ, and how long is that? 6. And it's asking us to find the length of QR. How do you think we would do that? Do we add those two together? We subtract them. This time they gave me the length of the big one and one of the small ones. So if I want to find the other one, I simply subtract. I'm just going to put over here what I did in case anybody's curious. We added those. And then here we're going to take the big piece, the 13, and we're going to subtract the small piece, and that's going to tell me that the length of QR is 7. Is it? Yep. Give me just a minute. Let me try to write this. Whoops, that's not what I want to write. So the length of QR is 7. Excuse me. You can just put 7. I'm just showing you how everything's represented. All right, I want you to go ahead and try the next one. Try that next example. Pay attention to your picture. What do we think we should do for this one if I want to know the length of PQ? Subtract. What's the bigger one? So we're going to do 24.3, and we're going to subtract the smaller one, which is 17.8, and how much does that give me? 6.5. Yep, so the length of PQ is 6.5. Round it to the nearest tenth, that's 1 decimal place. If they asked me to round it to the nearest whole number, yes, it would be 7. Is everybody good? All right. Now this next one's a little bit more challenging. First of all, it doesn't give us a picture. Second of all, it has variables in it. So here's what we need to do. Let's read the first sentence. Find the value of x and the length of BC if B is between A and C. So the first thing I want you to do is draw what that says. Draw yourself a segment where B is between A and C. Doesn't matter where between, just somewhere between. We want to draw our segment. What are the endpoints of that segment? A and C. Okay, so I'm going to draw that, and I'm going to label my endpoints A and C. And then I'm going to put B somewhere between those. It doesn't matter where. It just needs to go somewhere between. Okay, so I can draw a picture. Pictures help us label. That helps us see what we're doing. Okay, I would never ask you to do this, or I would never recommend that you do this without drawing a picture. All right, now let's look at what it tells me. What's the next thing it tells me? AC is what? Okay, so that means from A to C, all the way from A to C is 4x minus 12. All the way here. Is that the whole segment? Okay. what's the next thing it tells me? AB is x, so in between here and here is x. And then it tells me that BC is what? So in between B and C is 2x plus 3. So you see how I'm labeling it? I put the whole thing up at the top, the 4x minus 12. That's the whole segment. I labeled BC as x. That little squiggly is just showing you that I'm talking about that entire length there. And then BC is 2x plus 3. What we have to do is we have to figure out how we can set up an equation so that we can solve for x. No, because we don't know that B is in the middle. We just know it's in between. What was the second thing you just said? We're going to have to get to some like terms in a minute. Okay, what are my two small segments? AB and BC, right? What is the length of AB? What did we call it? X. Okay, so there's AB. Whoops. That's my small segment. I'm just writing it up top. You don't have to write that AB. And then what's the other small segment? It is 2x plus 3. That's BC. And what should I do to those to get it equal to the big one? What's that postulate called? The segment. Look back on the front of your paper. Segment what postulate? In that box at the bottom. Segment addition postulate. So I'm going to take AB, which is x, BC, which is 2x plus 3, and I'm going to put them together, which in math means I'm going to add them, and they are going to equal the whole segment, which, what are we saying the whole segment is? 4x minus 12. Okay, does everybody kind of understand that? I take the little segment. Let me see, my highlighter helps. AB, okay, that's the little segment. And then I take the other small segment, BC, which is 2x plus 3, and that is going to equal the whole segment, which is the 4x minus 12. Does that make a little bit of sense? All right. Now, let me erase my highlighters so that I can solve this equation. Think about this. This is where our algebra skills come in. My equal sign is like a fence. I need to simplify each side of that fence before I start moving things from one side to the next. So let's look at the left side of the fence. I've got x plus 2x plus 3. Do I have any like terms that I need to combine? 2x and x, and that's going to give me how many x's? 3x. Okay. Is there anything to combine with that 3? No. So I'm just going to put it down right now. Not moving anything just yet. We're just simplifying. What about the right side? 4x minus 12. Does that have anything to combine? No. All right. Now, we want to get all of our x's on one side of our fence and everything else on the other side of the fence. It doesn't matter which way we go. However, most of us try to stay away from negatives, I think. So how many of you would say you want to move the 3x over to the 4x? And how do we move it over there? Subtract it, yep. So I'm going to subtract my 3x over. And I'm going to run out of room here in just a second, so I'm going to have to go to the side. 4x minus 3x is 1x. And I'm going to come over here. So I have 3 equals x minus 12. How do I finish solving that for x? It's x minus 12. How do I get rid of that minus 12? Add it, yep. So we're going to add. Remember, we do opposite operations. If we're adding, we subtract. If we're subtracting, we add. If we're multiplying, we divide. And if we're dividing, we multiply. So what is x? 15. Okay, so it asked me for x. That's the first part of the question. What else did it ask me for? BC. How do you think we should figure out how long BC is? What does it tell you BC is over here? Plug it in, yep. So BC is 2 times x plus 3. But what do we know x is now? So we're going to go 2 times 15 plus 3. Which tells me that BC is 33. If I wanted to find AC, could I do that as well? Yeah, I could plug it in, or I could just add those two together. So far, so good. That was a little harder because we got to throw some algebra into it, but we're going to do that. Anybody have any questions? All right, last one. Take a minute and read that question. Then we're going to set up a picture for it, okay? Read your question. says Daryl is visiting the Space Needle in Seattle, Washington. He knows that the total height of the Space Needle is 605 feet. The distance from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. Help Daryl find the distance from the ground to the observation deck. Okay? Everybody? So, I am no artist. I do not expect you to be an artist. I don't even know what the Space Needle looks like, to be honest with you. So, I'm just going to draw that. That's my Space Needle. Okay, you can also just draw a line. Okay, it's obviously standing up and down, I would assume, if you have an observation deck. And what does it tell us the total height of that Space Needle is? 605 feet. So I'm going to label that as well. That's 605 feet. Geometry is a very visual math, so we will have to represent a lot of these things that they're telling us. Now, we have an observation deck somewhere. I'm going to think it's probably pretty high. So I'm going to call this my observation deck. You don't have to draw it as elaborate as I am. Like, that's an elaborate drawing anyway. But so somewhere for the people to go up and observe, right? What is it we're looking for? What does it ask us to find? The distance from the ground to the observation deck. So what can we call that if we don't know it? X. So from the ground, here's the ground right here, to the observation deck, that's X. So I'm going to put an X if my pen would write. Yeah, right there. You see where I put X? That's representing this distance right there. Now, this is what we need to focus on. The distance, I didn't finish reading my question. We're going to erase that X. My bad. I didn't read the question. So what it says is the distance from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. Okay. So does it tell me something about the top part from the observation to the top, or does it tell me something about the observation to the ground? Observation to the ground. So I know a little bit about that. So we really need to put our X at the top then. Okay. This is what they didn't tell me anything about, is how far it is from the observation deck to the top. Yeah, thank you. I lost what I was trying to say. Now what we need to figure out is how to write 10 more than. So think about math. Let's write the number 10. What is more than? Add, subtract, multiply, divide. Add, okay. 6 times the distance to the top. What did we call the distance to the top? X. How do I write 6 times that? 6x. Okay. 10 more than, come on, 6 times the unknown. So that's going to go down here. Right down here is 10 more than 6x. Do we see how we represented those? We didn't know anything. They didn't tell us anything about the distance to the top, but they did tell us about from the ground to the observation deck. Now, what are my 2 smaller segments? How did we represent them? In my green, how did I represent them? What's the distance from the observation to the top? X, okay. Plus, because we're going to have 2 small segments to give me a big one, what's the distance from the ground to the observation deck? And that is going to equal the entire height of the Space Needle, which we said was? Okay, so what I want you to do is solve that for X for me. We labeled each piece. We added the 2 smaller portions and set them equal to the larger one. And we're going to solve for X, but we have to make sure eventually, once we figure out what X is, we have to make sure that we actually answer the question. Okay. If you're not real good with equations, remember the equal sign is like a fence. We want to combine anything that's the same on either side before we start moving stuff. then we can get that x by itself. And then we can divide. Did you guys get 85 for x? Everybody get that? Okay, here's my question. Let's go back and see what we're supposed to find. We want to know the distance from the ground to the observation deck. Is that x or is that 10 plus 6x? From the ground to the observation deck. 10 plus 6x. So what do you think I need to do with that 85? Plug it in. Yep. So we're going to go 10 plus 6 times 85. And that is going to give me the total distance from the ground to the observation deck. So I am going to use my handy dandy calculator because I use tools that I can anytime I can. Multiply 6 times 85, and I'm going to add 10. And the total distance from the ground to the observation deck is 520 feet.